Once again, welcome back with another an important class, and you are able to see here. Yes, I am going to explain class 11 mathematics. I know you are quite intense and eagerness, okay, after your class 10, and which you have done excellent in your exam. I see. Now you are looking forward to your class 11. So in this regard, in this context, I am going to explain of your additional mathematics problems in vividly for you, okay, and also along with that I am discussing the important concept behind it. I hope this is my first class. I hope and you will take interest and eagerness towards the class, and we'll go through vividly. Yes, okay, and also we'll practice the different and various kind of concept problems based on the concept of. So in this class I am going to discuss about class 11 mathematics. Okay, understand? And all of you know in class 11 mathematics is the most vital and which is the foundation, gives the foundation to class 12 math and has many applications in various life. You have to face the different kind of competitive exams in IIT and JEE, and class 11 mathematics is the most significant in this regard, which you cannot discard. So you have to take importance of class 11 mathematics in this regard. And here I am going to discuss the first chapter, set theory, for you of your class 11 mathematics. And you know there are two important concepts of the class 11. You will study relation and function, which gives to the foundation of the what? Calculus, integration, derivative, and their widely application. You will study which are mostly useful in physics. So without relation and function, you can't understand calculus, and without calculus, your physics will be meaningless. Similarly, set theory is also take the vital role in helping and understanding, gives a clear idea about the concept of relation and function, without which relation and function is difficult to understand. So you need to understand, take importance the chapter set theory, which I am going to discuss of your additional mathematics. Where I am going to explain vividly the solution of the additional with various problems from your additional books. And before discussing, I am going to explain, yes, the basic concept of set theory. What is set theory and who is the founder of set theory? Okay, so your topic is set theory, first chapter of your class 11 math. And set theory has many applications in your practical life. Various problems in our everyday life we can solve along with the application of the set theory, which is most inevitable in every aspect. Look at an interesting question here. In a school, all pupils play either hockey or football or both. 400 play football, 150 play hockey, and 130 play both games. Find the number of pupils who play football only, the number of pupils who play hockey only, the total number of pupils in the school. This is one of the important vital problem, and without set theory, without the knowledge of set theory, it is not possible to answer these questions. And set theory in this regard has a great role in solving the various problems in our day-to-day life and most of the critical problem, and we can solve with the help of the concept of knowledge of set theory. Here is another problem, interesting problem, and just I will explain these questions, but before that you should know the significance of set theory, how the set theory can be useful in our everyday life. In a competition, a school awarded medals in different categories, 36 medals in dance, 12 medals in dramatics, and 18 medals in music. If these medals went to a total of 45 persons and only 4 persons got medals in all the 3 categories, how many received medals in exactly 2 of these categories? Is not an interesting question. And set theory has a great role in solving this kind of problem. So you need to take proper care about the topics set theory and the set operation. So let me see who is the founder of set theory. George Cantor, whose full name is George Ferdinand Ludwig Philipp Cantor. Born in March 3, 1845, St. Petersburg, Russia, and died in January 6, 1918, Halle, Germany, who was a German mathematician, was the founder of set theory. So George Cantor was the founder of the set theory, who laid the foundations of the set theory. The concept of set theory was initiated by George Cantor. So before discussing the question answer, let me discuss the defined set. What is set? What is set? A set is a collection of well-defined elements, objects or members. For example, I am giving a simple example of geometry works. And the purpose of geometry works should be useful. And what are the different objects are there? A pencil is there, without which you cannot do a construction work. You cannot draw a line. A scale is there. And a rounder is there to do the different kind of construction. Without which, without rounder, can you do the construction? Without scale, can you draw a line? No. So, the elements of the geometry box are well defined. Pencil, protractor, compass, divider, etc. are the elements which are most inevitable and essential for the geometry box to do the different kind of construction for a certain geometrical work, different geometrical work. So the elements, so what are the object in the geometry box? These are known as elements or members, and which must be well defined. Because if say, suppose you say spoon, a spoon is not required for the geometry box. A glass is not required for the geometry box for the construction. So the condition that the set is a collection of togetherness of well-defined elements. The elements is a collection of elements, and the elements must be well-defined, and the elements of the set are also known as the object or the members. So how to represent a set? A set is usually represented by the capital letter of English alphabets, okay, such as capital A, capital B, capital C, capital D, etc. The elements of the set are usually denoted by the small letters of English alphabet such as small a, small b, small c, small d, etc. Or also we can use the numbers or symbols to represent the element of the set. If A is an element of the set A, we can write it as A belongs to A. This is the notation of the set A belongs to A. The element should be written first and the set written in the right side and belongs to sign. So A belongs to A means A is an element of the set A. And the element A must be well defined. Condition is that this element A must be well defined. If B is not an element of the set A, we can write it. How can we write it? B does not belongs to A, and read it as B does not belongs to A. B is not an element of the set A because the element B is not well defined to be the element of the set A. That's why B does not belongs to A. Representation of the sets in set theory. There are different set notations used for the representation of the sets in set theory. They differ in the way in which the elements are listed. There are three notations used for representation of the set. First one is the semantic form. Second one is the rooster form. According to mathematics and rooster, set builder methods, set builder forms. So representation of set in set theory, you see, semantic forms, rooster forms, set builder forms. You see here a set of 5 even natural numbers in the semantic form in the form of statement. Here rooster form, it is written, all the elements are written distinctly clearly within the curly bracket. in the rooster form. In the builder form, it is written in the property method or symbolic notation of the set. X belongs to n such that x is less than or equal to 10 and x is in n. I will discuss one by one. So what is semantic form? The semantic form is a kind of notation of the set which can be expressed, which can describe a statement to show what are elements of a set. The set is expressed in the form of statement is called semantic form. For example, we can say a set of first five odd numbers in the form of statement, a set of natural numbers in the form of statement, a set of whole numbers in the form of statement. So the set is described in the form of statement is called semantic form. Set of integers similarly, it is in the form of which way? Semantic form. So it gives idea about what kind of elements are there, and the elements of the set are always well defined. So what is rooster forms? In these forms, it is the most common form used to represent set in the rooster notation, in which the elements of the set are enclosed in curly brackets separated by commas, and in this set you have to write all the elements distinctly clearly by giving comma, and all the elements must be enclosed by what? Within curly bracket. For example, you see here is in set V, the elements are, you see, the opening curly bracket 2, 4, 6, 8, 10, closing curly bracket. You see all the elements, these are the 5 even natural numbers, and all the elements are written including enclosed by curly bracket and separated by comma is the collection of the first 5 even natural numbers. In a rooster form, the order of the elements, the set does not matter. The order of the elements of the set does not matter. You can write the elements in any order. For example, the set of first 5 even numbers can also be written 2, 6, 8, 10, 4. So the elements will be same, and the set does not vary. The element can be written in any order. It does not affect the set. The set will be same. Okay? For example of the rooster methods, you see the set of natural numbers, capital N, it is written is an infinite set. So you see curly bracket, opening curly bracket 1, 2, 3, and closing curly bracket. The dots can indicate that the element has infinite number of the set of natural number has infinite number of elements, and it is an infinite set. You will study infinite set, the set having infinite number of elements. If the set having infinite number of elements, you can use the dot sign. It shows the elements, the set has infinite number of elements. A set of whole numbers, which is capital W, which is opening curly bracket 0, 1, 2, 3, which is also an infinite set, and it contains infinite number of elements. The set of integers capital Z, which is, you see, also it is an infinite set. So these are the example of set, how to write in the rooster method, rooster form, rooster methods. Okay, this is one of the concept how to write a set in the rooster method. Next point, the important point is the set builder methods. Set builder methods, the set builder forms. And in these forms, the set builder forms, all the elements have common properties. The set builder notation has a certain rule or statement that specifically describe the common features, characteristics, or property of all the elements of a set. And in this set builder methods, we should not write all the elements distinctly, and all the elements should be written by single variable, and all the elements have a common properties. The set builder forms uses a vertical line, vertical bar, or a semicolon in its representation with a text describing the characteristics of the element of the set. For example, you write A is equal to K such that K is an even number, K is less than or equal to 20. This symbol is vertical bar line is known as such that line. We can use the semicolon. Here on the right side of the semicolon, vertical bar, and here you write the properties of element, properties of the set, and here before the bar line you see the element single variable k. K is the single variable. We can represent all the element of the set. Thus A is equal to k such that k is an even number, k is less than or equal to 20. It means the statement says all the elements of set are even natural numbers whose less than or equal to 20. This is the set in the which form builder terms. Sometimes we can use the semicolon symbol in place of the vertical bar line, which is read as such that, and on the such that line, this line is the vertical line. On the right side you have to study what? The properties of the set, and before the is the element of the set. Here the element is represented as single variable. We should not write all the elements in the builder methods. Similarly, some more example you see here. Set of natural numbers, capital N is equal to x such that x belongs to n. Set of whole numbers, capital W is equal to x such that x belongs to W. Here semicolon is used in place of vertical bar line. Set of integers, capital Z is equal to x such that x belongs to Z. Okay. This is the concept of set theory, represents of set theory, and how to write the set theory, and what is the significance of set theory. Here I am going to discuss the first exercise of your Sharma books, class 11 mathematics, chapter 1, exercise. Okay. First exercise I am going to discuss 1.01 and question number 1. And I am going to discuss vividly one by one for you, and which is very simple and concept I am going to discuss for you. So I am giving pen for you. I hope you will follow the class, and also okay, and also practice the problem. Let's see question number 1. What is the difference between a collection and a set? Already you know what is set, and set determines the collection togetherness. So is there any difference between collection and set? And you know, see here. See here students, what is the difference between a collection and a set? Okay, and we know already that a set is a collection. Set is a collection of well-defined element. It means element of the set must be well-defined. But here is an example I am giving. The collection of all great cricket players in India is not a set, because the collection of all the cricket players, but the collection of all cricket players is a set. Yes or no? Because why? The collection of greatness is not well defined. Great cricket player, it may differ from person to person, and the collection of cricket players is a set, because the elements collection of cricket players is well defined. So every collection is not a set, but set is a collection of, every set is a collection. Thus it is clear that every set is a collection and every collection is not a set. This is the basic difference between a set and a collection. Okay, let's see another simple problem of your Sharma books. I am going to discuss exercise 1.01, question number 2.01 I am going to discuss. Which of the following collection are the sets? Justify your answer. Look at the question here. A collection of all natural numbers less than 50. Can you say is it a set? Yes. Collection of all natural numbers less than 50. Look at here. A collection of all natural numbers less than 50 is a set. Why? Because the collection is well defined. Collection of natural numbers is well defined. We know how to write what are the elements in the set. You see now, the set is equal to the set of, you see you can write the set as 1, 2, 3 up to 48, 49. These are the elements, okay, less than 50 of the natural numbers. Since the elements are well defined, and you can write the set in the rooster methods. Okay, understand? So the collection of all natural numbers less than 50 is a set, because the collection of natural numbers is well defined. Next, question number 2, question number 2.02, exercise 1.01. Collection of good hockey players in India. Is it a set? Good hockey player. See, you say collection of the hockey players is a set. Good hockey players, the collection of good hockey players is not a set. Because the collection of goodness is not well defined. And choice of goodness differs from person to person. So the collection of good hockey player is not well defined. But collection of hockey players is well defined. So the collection of good hockey player is not a set, but the collection of hockey players is a set. Understood, all of you? Very simple concept. The element must be well defined, very important concept of the set. The collection of all the girls in your school, is it a set or not? Yes, it is a set. Because you can understand, you can write all the girls, name of all the girls in your school. And the collection of name of the girls is well defined. So the collection of all the girls in your school is a set because the collection is well defined. Similarly, another question, question number 2.04, exercise 1.01. Which of the following collection are sets? Another question is here. Question number 2.04. The collection of most talented writers of India. Talented writers. Talented writers cannot be, because the word talented will differ from person to person. A writer may be talented for one person, but may not be talented for other person. You know, right? So the collection of most talented writers in India is not a set, because the collection of talented writer is not well defined. So the collection of most talented writers of India is not a set. Question number 2.05, exercise 1.01. Another question, question number 2.05. The collection of difficult topics in mathematics. Difficult topics. The word difficult, the collection of all topics in mathematics of your class 11 can be, but collection of difficult topics cannot be set, because it varies from person to person, student to student. A topic may be difficult, may be easy for other. So the collection of difficult topics is not a set. Yes, the collection of difficult topics in mathematics is not a set, because the collection is not well defined and varies from student to student. Next, question number 2.06, question number 2, bit 06, 6 bit, exercise 1.01, last exercise. Here is another simple question. The collection of all months of a year beginning with letter J. Yes, is it a set? Not a set? Yes, it is a set. Because the collection of all months of a year beginning with letter J is a set, because the collection is well defined. The collection of all the month of a year beginning with letter J is a set, because collection is well defined. And the set is equal to what? Which the set you can get? You can write the set in the rooster methods, January, June and July, for 3 months. So the elements are well defined. That's why the collection of all the month of year beginning with letter J is a set. Right? Let's move to another question. Question number 2.07. Question number 2, bit 7. Exercise 1.01. Another simple problem. Look at the problem here. Simple statement. We say, which is a set, which is not a set. Very simple, you can understand, I think. The collection of novels written by Munshi Premchand. Yes. What are the novels written by Munshi Premchand? We can collect, and it can be said the collection of novels written by Munshi Premchand are well defined, so it can be said. Yes. So collection of novels written by Munshi Premchand is a set because the collection of novels is well defined. Okay. So next question is question number 2.08, question number 2, 8-bit, exercise 1.01. Here is the question. The collection of all the questions in this chapter. You can say how many chapters are there in your, you can say how many questions are there in the chapter. You can collect, you can write. So all the question, okay, you can ensure whether this question belongs to this chapter or not. So the collection of all the questions in this chapter is well defined. Yes, the collection of all the questions in this chapter is well defined because one can ensure whether it is a question of this chapter or not. So the collection of all the questions in the chapter is a set. Next question number 2.09, question number 2, 9-bit, exercise 1.01. Look at the question here. A collection of most dangerous animals of the world. The word dangerous animal, which will differ from person to person, vary from person to person. So the dangerous animal is not well defined. So collection of most dangerous animals of the world is not a set. Because the collection of dangerous is not well defined. And it varies from person to person. Dangerous animal is not well defined. It varies from person to person. So it cannot be set. Here question number 2. Next question I am going to discuss. Question number 2. First bit 2.1. Exercise 1.01. Similar type of question. Same question as question number 1. The collection of prime number. Is it a set? Yes, it is a set. Because the elements are well defined and you can write the set in the roster methods and also in the builder methods. 3 format we can write. Here the set is 2, 3, 5, 7. Okay, it is an infinite set and this is a elements are well defined. Okay, so the collection of prime integers is also a set because the elements are well defined. Collection is well defined. Exercise 1.01, question number 3. Next question I am going to discuss, question number 3, first bit. Just you see that using the set notation. You have to use the set notation and you find which is the, using the set notation with the answer. You see here, if the set A is equal to opening curly bracket 0, 1, 2, 3, 4, 5, 7, 8, 9, 10, then insert the appropriate option belongs to or does not belongs to symbol in the following blank. You see here 4 is an element and here A is the set. Between the element and set, what is the symbol you have to relation belongs to, or you can give belongs to or does not belongs to. You cannot give two sign belongs to or does not belongs to between the two set. Between the element and the set, you can give the symbol, give the relation, give the notation belongs to, does not belongs to. You see here 4 is an element. If you see clearly, the 4 is an element already in the set A. So the 4 is an element, 4 belongs to A. You can write 4 belongs to A. Very simple notation of the set. Whether 4 is an element or not, clearly by looking at the set, you can understand. Similarly, same question, question number 3, the second bit, I am going to discuss here. Okay. Look at here 12 is an element. Can you say 12 is an element of the set A? By looking you see 12 is not, doesn't it? Not here in the set A. Within the curly bracket there is no 12. 12 is not present. 12 is already absent. So you can write 12 does not belongs to A. 12 is not an element of the set A. Yes or no? Because the set is finite set. There are only numbers up to 10. 12 is not there. 12 does not belong to A. 12 is not an element of the set A. Question number 3.4, exercise 1.01. Okay. Look at here. Here you see 9 and A. What is the option is there? 9 and A. 9 is an element already there. So you can write. Yes. Tell me. Have a thought. You can say I know. 9 belongs to A. 9 is an element of the set A. Here you see 0 and A. You see clearly 0 is also an element of the set A. We can write what? Yes, 0 belongs to A. Understood? Yes. How easy? The set theory is. The chapter is very lucid chapter for you. And an interesting chapter. Question number 3.6, exercise 1.01. Look at here. Here minus 2 and A. You see minus 2 is not an element in the set A. There is no negative numbers are there. So minus 2, see, does not belongs to A. Minus 2 is not an element of the set A. By looking at the set, you can see clearly. So here is an assignment for you. I hope, and which of the following sets are well defined. Which of the following are well defined sets, and you can say whether they are set or not, and you can say them. Okay. Okay. So you can do it. Try for your best. Yes. Understand? This is my first class, and I hope you will understand. And I am going to continue this class for you and for your betterment. I hope you will enjoy the class. Okay. Thank you for your patience, interest, and eagerness toward the class.